The incredible evolution of F1 engines. F1 is a sport that has evolved a lot through the years, and one of the parts that have endured the biggest evolution is the engine. Throughout the years, F1 cars used different types of engines, and they got changed over the course of time. As of 2022, F1 cars are using V6 1.6-litre turbocharged engines, but it wasn't like that just a decade ago. F1 engineering has reached the pinnacle of its existence when it comes to the Formula sport, and in this video we're going to discuss how F1 engines evolved over time. So buckle up and get ready to be blown away. F1 fans know that the sport is currently mandating that all teams need to use the same sort of engine, which we mentioned earlier in this video, and that is 1.6-litre V6 petrol engines. But it wasn't like that during the 1950s, as F1 cars were running on all kinds of engines, from custom-built inline 4s to V8s. The only regulation that was running through this era of F1 was on engine displacement. If the engine was naturally aspirated, then the capacity was limited to 4.5 litres, while if the engine had a supercharger that boosted its performance, then the limitation was 1.5 litres. During this time, the engines produced around 425 horsepower, meaning that the cars produced 94 horsepower per litre. But in 1952, there were stricter regulations when it comes to engines, and the only engine that was allowed was the 2.5-litre, naturally aspirated one. This meant that the horsepower was cut down to 290, and on track the cars were supposed to be much slower compared to the previous years. However, teams found a way around this rule and have played with the design of the engines. And not only that they weren't slower, but the engine was able to produce 116 horsepower per litre. Therefore, the efficiency has risen a lot. If we take a look at the grid from 1952, we can see that the cars were running on inline 4s and 8s, as well as V12 and V16s. But the problem with these engines was that they were too heavy, and they were fitted in front of the car rather than in the back, as we are used to seeing now. This meant that the drivers produced a huge amount of understeer, which forced the drivers to slide around the corners in order to neutralize it. During this decade, another massive evolution was discovered, and that is the usage of the mid-mounted engines. The first constructor that implemented this was the Cooper T43. The center of gravity was placed further in the car, so the understeer wasn't as present as it was before. However, the speed of the cars was a huge concern for the safety of the drivers at that time. The cars were able to develop a speed at around 180 miles per hour, and without any crash protection in the cars or barriers, so fatal accidents were pretty common. Therefore, the FIA decided to intervene and implement the 1.5-litre engine in 1965. The cars initially produced 150 horsepower, but then this number was increased to 250 horsepower, meaning that the cars effectively produced 170 horsepower per litre. There was a huge problem with this regulation, as GT and road cars were faster than Formula 1 cars. Lap times effectively went down, and the sport started to lose its sense. During this time, V8 engines were used most frequently, but teams started to shape the V angle in order to place the engine lower in the car and have improved handling. From 1966 and beyond, the FIA has increased the amount of horsepower and the volumes of the engines too, increasing it to 3.5 litres, naturally aspirated, or 1.5 litres with compressed air. The teams mainly used mid-mounted engines that produced around 500 horsepower. One crazy idea that was implemented this year was the H16, in which two V8s were essentially bolted together. It actually made sense to take two 1.5-litre engines and make them 3.0 H16 engines, which is considered to be one of the craziest engines that were ever invented in the sport. During the 70s, there was a new invention that made cars run with flatter engine blocks. The teams have mounted the V12s under 180 degrees, essentially making a flat 12. By doing this, the engine was mounted low and the center of gravity was brought down, and the airflow was cleaned up to the rear wing. The regulations remained pretty static throughout the 70s, as the teams had a choice to use 3.0 naturally aspirated or 1.5 compressed air engines, with the former being used more frequently. In 1977, a huge step towards engine evolution was made by Renault, as they came with the 1.6-litre V6 turbo engine, which produced 500 initial horsepower but soon got to 700 horsepower. This is actually the beginning of the turbo hybrid era, but this engine was full of flaws, as the heat was causing the ignite of the fuel prematurely, and the engine was blowing up. Over the next years, all of the teams adopted a similar concept when it comes to engine development, as they used water injections to cool the block more evenly. At some point, some of the cars used a toluene fuel that actually gave the chance of an F1 car to produce up to 14 horsepower under 5.5 bar pressure. But since this was too much for an F1 car to handle, the teams had to turn down the engine, and it produced around 800 horsepower. During this time, the F1 sport was also introduced with the ground floor effect, and in a combination with the toluene fuel, the sport became unstable and risky yet again due to the huge amount of speed. In 1989, F1 went turbo-free, and the sport introduced 3.5-litre naturally aspirated engine. It was one of the biggest shakeups in the sport, as teams were divided since they had to build entirely new engines to meet the new regulations. The Honda engine was the best of the other manufacturers, producing around 675 horsepower with the V10. You'll probably notice by far that the horsepower per litre has reduced, but it was mostly because turbos were banned along with exotic fuels, and there were tighter regulations on how long the engines had to last. However, during the turbo era, F1 teams started to make their engines out of materials like titanium and beryllium in order to withstand the power of the turbocharger. Although they were used to withstand the power of the engines back then, now these materials are used to reduce the weight and allow higher revs. For the engine to produce more power, it needs to rev much more. But with more revs, the valves have to also move much faster, and with a traditional camshaft system, the timing of this could become much tougher to control. How did Honda fix this problem? They used high-pressure air to move the valves with much more accuracy, also known as pneumatic valve control, and it is a system that is used to this day. Towards the end of the 1990s, the engines have evolved to around 800 horsepower, and they were producing the same power as when the turbos were allowed. During the 2000s, there were strict regulations when it came to the speed of the cars, and the cars were using 3.0-litre naturally aspirated engines. Apart from this, the FIA banned the exotic alloys that were extensively used in the 90s. The V10 was vastly used during the 2000s, as it was more reliable than the V12s and used less fuel compared to the V8s. These cars produced around 900 horsepower, meaning around 300 horsepower per litre. In 2009, CARES were introduced, or more precisely, Kinetic Energy Recovery System. This meant that the engines were able to regenerate energy from the rear brakes and deploy up to 80 horsepower for around 6 seconds a lap. It was really a test for the 2014 regulations when we saw the implementation of the turbo hybrid era, one that was vastly dominated by Mercedes. The engines were changed too, and they were still driven to this day, as we said earlier in this video. The 1.6-litre V6 engines produce around 1,000 horsepower. Car manufacturers started to produce more economical engines for their road cars, so it was only natural for them to implement this in the Formula Sport. One massive introduction here is the hybrid technology, and it was truly an innovation that changed the sport. Thanks to the electrical components of the car is more economical and eco-friendly, and from 2026 onwards, the cars will move towards more electrification, and they will use more sustainable fuel, possibly up to 100% fully sustainable one. This was our video of how the engines have grown to be what we are seeing today. Let us know in the comments below, how do you feel about them?